In grade 10, we looked at the equations of motion in the mechanics section. We concentrated mainly on horizontal linear motion. In this video, we will be looking at vertical motion problems. These equations are always available and remain the same for vertical motion. Note that x is used for the change in horizontal position and y is used for the change in vertical position. These equations can only be used for motion in a straight line, which is also called rectilinear motion, so we deal with horizontal and vertical motion separately. For vertical motion, the acceleration for free fall is used where the acceleration of gravity is equal to 9.8 meters per second squared. These are vector equations, so choosing a direction is important. So often the direction the object is initially moving in is positive. If an object starts from rest, the initial velocity is 0, vi equals 0. If an object stops, the final velocity is 0, vf equal to 0. If an object is speeding up, the acceleration a is positive. If an object is slowing down, the acceleration a is negative. When discussing vertical motion, we need to take the following points into consideration. A body accelerates in the direction of the unbalanced force according to Newton's second law. So when a rocket lifts off, the upward force or thrust is greater than the gravitational force acting on rocket. That makes the resultant of these two forces upwards. So the rocket accelerates in an upward direction. When an object is thrown up into the air, after it leaves the hand that threw it, the only force acting on it is its weight. And the direction of this force is vertically downwards. The force is given by the equation W is equal to the mass of the object multiplied by the value for gravity. Sometimes weight is written as Fg, or force of gravity. As the body falls downwards through the air, its velocity increases because its acceleration is in the same direction. As it falls and speeds up, upward air resistance acting in the opposite direction starts to increase. When the gravitational force down is equal to the air resistance, sometimes termed drag, there is zero resultant force, and the body is said to have reached terminal velocity. That's easy to see when some objects no longer accelerate in air. Now, as a body rises up air, its vertical velocity decreases because its acceleration is in the opposite direction to the motion. The velocity vector Vy can be seen decreasing as the ball moves up. As the ball returns to the ground, the velocity increases in the downward direction. This is shown by placing a negative in front of the value. The velocity vector Vy can be seen as increasingly negative as the ball comes down. The difficult thing to understand is that the horizontal velocity remains the same. Remember that the acceleration of all objects which are traveling with vertical motion is called gravitational acceleration. It is the value 9,8 meters per second squared, and the real secret is that it is the same in every question. The acceleration is denoted by the letter G. Gravitational acceleration remains constant throughout the motion of the object. It is even 9,8 meters per second squared when the body is at maximum height, but at its maximum height, the vertical velocity of a body is 0. It is true, at the peak, a body has an instantaneous velocity of 0, but since acceleration is constant, it moves through this value smoothly without pause. The magnitudes of upward and downward velocities at the same heights are the same during the whole flight. The next point to consider is time. The time taken to cover upward and downward displacements that occur between the same levels are equal. When we say that a body falls freely or that it is in free fall, we imply that it falls under the influence of gravitational attraction only. That is, there are no negative effects from the air resistance. A body which is thrown horizontally outwards from the height above the ground has two simultaneous motions. One, it accelerates vertically downwards from the rest at 9,8 meters per second squared. Vi is equal to 0. 2, it travels horizontally outwards with constant velocity. Since a body thrown horizontally outwards accelerates vertically downwards at 9.8 meters per second squared, it takes exactly the same time to reach the ground as it would if it were dropped from this height. So if you throw something horizontally at any speed or drop it, it would strike the ground at the same time, albeit in a different horizontal place. Let's talk about signs and vectors. Upward velocities should be given a negative sign. Downward velocities should be given a positive sign. Displacements that are above the starting point must be given a negative sign. Displacements that are below the starting point must be given a positive sign. Gravitational acceleration should always be taken as plus 9,8 meters per second squared. You can swap all of these, but it does not make calculations more difficult. Let us look at vertical problems and solve them. If you struggle with word problems, keep the following in mind to simplify things. Always write down the information first. Then select the correct formula. Substitute and calculate. Check the units for the answer. State that down is positive. If your maths is poor, do not rearrange the formula until after the substitution. Here is a typical example. A brick falls off the wall at a height of 20 meters above the ground. A. How long is it in the air? B. How fast is it traveling after 1 second? Let us take down to be positive. Maybe draw a downward arrow to show it. We know that the initial velocity is 0. The vertical displacement is positive 20 meters and that gravity will be positive 9,8 meters per second squared. Look at the question. We see that it is asking for time, so we use an equation of motion that does not have the final velocity in it. The change in position is equal to the initial velocity times the change in time plus half times gravity times the change in time squared. Substituting in the values, 20 equals 0 plus a half times 9,8 times change in time squared. You then work out half times 9,8, which gives you 4,9. To get time on its own, you divide, so 20 divided by 4,9 is 4,082. Taking the square root, you get the answer of 2,02 seconds. It often happens that either time looks negative or you are required to find a square root of a negative number. That means you messed up a sign. Go back and check. Part B asks how fast it is traveling after 1 second. If we look at what we have, the initial velocity is 0, the time is 1 second, and gravity is 9.8 meters per second squared. We thus choose an equation of motion without change in position. So, final velocity is equal to the initial velocity plus gravity times the change in time. Substituting the values in, so final velocity is equal to 0 plus 9,8 times 1, giving us an answer of 9,8 meters per second down. Remember, velocity is a vector, so it needs direction, and we choose down as positive. It's important to write down the direction with vector answers. Let us look at another example. An object is launched from a rocket thrower straight up with an initial velocity of 50 meters per second. A. How high does it rise? B. How long does it take to reach its greatest height? Choosing down as positive, we extract the relevant information that the initial velocity is minus 50 meters per second. The gravitational acceleration is positive 9,8 meters per second, and the final velocity at the peak is 0. In part A, we are looking for the vertical height. Here we need to choose an equation of motion without time in it. So final velocity squared is equal to initial velocity squared plus 2 times gravity times the change in vertical position. Substituting, we have 0 equal to minus 50 squared plus 2 times 9,8 times the change in vertical height. Solving the change in vertical height, the minus 50 squared moves across the sign and is then divided by 2 times 9,8. The answer is negative 127,55 meters. Interpreting the answer, the minus means it is in the opposite direction to that has been chosen. Thus, the object rises to a height of 127,55 meters up. Looking at part B, where it asks how long it takes to reach its maximum height, we have to choose an equation without displacement. We know that the velocity at maximum height is also 0. So we choose final velocity equal to initial velocity plus 9,8 times the change in time. Substituting into the equation, we have 0 equal to minus 50 plus 9,8 times the change in time. Taking the minus 50 across the equal sign and then dividing by 9,8, we get an answer of 5,102 seconds. Time is a scalar, so time is always positive. Falling bodies have constant acceleration. The following points refer to basic vocabulary that is seen in questions and will help you to interpret the questions asked. Free-falling objects are objects which, with no friction or support, accelerate downwards near the Earth's surface at 9,8 meters per second squared. Note, this 9,8 meters per second squared is an experimental value which can be proved. 2. To solve equations of falling bodies, use the equations of motion when 9,8 meters per second squared is downwards. 3. Drop means VI, initial velocity, equal to 0 meters per second starting from rest. Hint. Number 1. Always draw a sketch of the path of the object. Number 2. Label the sketch. Number 3. Work downwards where possible. VI, initial velocity at the top, is usually 0 and G downwards. Let's look at another example using vertical motion. A ball bounces to a vertical height of 0,9 meters when it is dropped from a height of 1,8 meters. It rebounds immediately after it strikes the ground, and the effects of the air resistance are negligible. Number 1. How long in seconds does it take for the ball to hit the ground after it has been dropped? Number 2. At what speed does the ball strike the ground? Number 3. At what speed does the ball rebound from the ground? Number 4. How long in seconds does the ball take to reach its maximum height after the bounce? So, solving this equation is done in parts. 4.1. How long in seconds does it take for the ball to hit the ground after it has been dropped? (4.2) At what speed does the ball strike the ground? (4.3) At what speed does the ball rebound from the ground? (4.4) How long in seconds does the ball take to reach the maximum height after the bounce? A handyman is laying tiles on the roof of a building. A tile of a mass of 1 kilogram slips from the hand and falls from point A at the edge of the roof. It passes by a window X, 20 meters below the roof. Ignore the effects of air friction. 1. What is the magnitude and direction of acceleration of the tile the moment it falls off the edge of the roof? 2. What is the magnitude of the tile's velocity at A? 3. A. Write down an equation that can be used to calculate the velocity of the tile at X. Write down the meaning of each of the symbols used in this equation. B. Calculate the magnitude of the tile's velocity at X. Number 4. Calculate the height of the window above the ground if the tile took 1 second to reach the ground from X. So you see, it's important to take note of every bit of the language in the question, making sure that you write down all the information. Here is a nice summary of the approach you should take. Draw a diagram even if you aren't given one. Decide a direction that is positive. It is often easiest to work with down as positive. Write down information, making sure you note the signs of each vector. Select an equation. The key is to find one without the variable that isn't mentioned or asked for. Only then solve and get your solution.